got some sand in it. And I put in just enough sand so that this sand is halfway from the bottom to the top. That distance from the peak down here, the vertex, the apex, up to the base here, that distance is called the altitude, halfway. The altitude is the perpendicular distance from the apex to the base of the cone. Now, how many times this amount of sand do you think I need before I could fill this whole cone? What do you think? 3 times? What do you think? 3 times? It looks like it might be 3. It's certainly more than 2, isn't it? Because the top is bigger than the bottom. So what do you think up here?
I'm thinking 4 or more.
4 or more? Anyone else ever guess? What do you think? Yeah.
3.5.
2.5?
3.5.
2.5? Yeah, we can use fractions. Yeah.
2.5.
Okay, so what's your name? Yeah, once you come down, well, if you're willing, we'll do a little experiment. The scientific way is, if you have a question about something, you run an experiment 4 or 5 times. Okay, once you have a chair. Now, okay, now this is not going to hurt. Now I have a cone here. It's got a mark there. I mean, you will see it. It's half of the altitude again. And a little water here. Now I'm going to fill this up to this mark, halfway mark, with water. And I'm going to dump it into another container. And I'm going to do that 6 times. Keep dumping it out 6 times. Then I'm going to pour the whole thing back in here. Or you say 6, right? Okay. Now, drop one. I know you're probably not afraid to get wet, but I want to make sure that you never know. I bring these along. Sometimes it backfires on me. So I'm going to fill this up. Oh, no, it's here. Is that pretty good? Straight on that. Okay, that's 1. All right. 3. I have to take a rest. That's heavy. Now you might want to get water. How many did I do? 3.
Jocelyn, put that on.
5. 6. You feeling brave? Should we go for 7?
Yeah.
That's 7. the truth now. Now, maybe we should have a drum roll for the occasion. What's that? Okay. Yeah. See, they make ice cream piles and things like that. They make cones like this for a good reason. If they fill it up so that it's fairly close to the top, you go down an inch, you probably wouldn't complain. But if it's down an inch, you're maybe losing a fourth of the volume of the container. Most of the volume of these things that flare out are up near the top. Okay, so that's kind of a good thing to remember. Another thing is to fill a cone up. Now it doesn't matter whether it's a cone like this or it may be a cone that's in a city water supply. Sometimes they have these huge cones and cylinders and so on. If that thing is half of the altitude, what fraction of the cone is filled? 1/8. I hope you guys all have a great summer, and thanks for coming. Here are some follow-up activities. Commercial cones and cylinders, such as these, can be used for experiments. With a cone filled to half the altitude, and we will call this a half cone, it can be shown that 8 of these half cones equals the volume of one large cone. Students can also show a relationship between a cone and a cylinder that have the same base and the same altitude. This cone needs to be filled 3 times to fill the cylinder. So the volume of the cone is 1/3 the volume of the cylinder. Since the volume of a cylinder is the area of the base times the altitude, the volume of the cone is 1/3 the area of the base times the altitude. Here is a cone that has a base with a radius of 2 inches and an altitude of 6 inches, and a half cone with a base that has a radius of 1 inch and an altitude of 3 inches. So the volume of the large cone is 1/3 times the area of the base, which is pi times the radius squared times the altitude of 6, and canceling 3 into the 6, we see that this equals 2 times 2 times 2, that's 8 pi. And the volume of the half cone is 1/3 times the area of the base, which is pi times 1 squared times the altitude 3, And once again canceling, we see this equals pi. So the volume of the large cone is 8 times the volume of the half cone. To go one step further, the numbers for these dimensions can be replaced by variables. The letter R for the radius, and the letter H for the height or altitude, and the radius of the small cone is R over 2, and the altitude of the small cone is H over 2. Then the volume of the large cone is 1/3 times the area of the base, which is pi r squared, times the altitude, and the volume of the half cone is 1/3 times the area of the base, which is pi r over 2 squared, times the altitude, h over 2, and this equals 1/3 pi r squared, we square the r, times h, and the 1/8 comes from the 2 squared and the 2 here, so we have the relationship that the volume of the small cone is 1/8 the volume of the full cone, as shown by the water experiment in this video.